This one's exciting. Of late, I have received a new piece of equipment in the shop, courtesy of our friends at Form Labs. They have given me a Form 3L large format resin printer to utilize. And it's a beautiful machine. The resolution is incredible. Even its low resolution is highly impressive to me. And I have many, many plans with this machine because I have not yet had a 3D printer in this space for my exclusive use. That just hasn't happened yet. I know that seems crazy, but it's the reality. Oh, also, if you're wondering what this is, I suffered a couple of years ago from tennis elbow. I don't play tennis, but I had tennis elbow, and I have got a little flare up, and so I'm wearing the arm brace to help me with that. But back to the 3D printer. The Forms resin printer, I've used it a couple of times. Most recently on the crown, I needed to make these little 5mm balls on strips for crown detailing. And it was the very first time I ever needed something, drew it, printed it, and used it. I had done each of those operations, but I hadn't done all of them for one project generated by me. And that kind of cut my teeth. And so each new piece of equipment is like a different lens with which to take a look at problem solving. It's like those things you go to the eye doctor, better, worse, better, worse. So the 3D printer does all sorts of stuff that I can do already, but it accelerates some things that would take me an incredibly long time. And so as I made those little ball strips for my crown and realized just how much the printer could chop out of a laborious build, I started to think, what can I build? Now, you've already seen the title of this video, so you know it's the Mandalorian's Ambar rifle. A few weeks ago, Norm and I detailed a pair of these. You only saw one, but we did two of them. This is War Machine Paintball's beautiful Mandalorian sidearm. This is a beautiful piece of aluminum, all CNC machined aluminum and steel. It's a beautiful kit. But Mando doesn't just have the sidearm, he also has this really formidable rifle, which is called an ambar rifle. And because it's got this like twin forked thing out at the end, it is known affectionately as the tuning fork. That's how I think of it, and that's probably how I will refer to it throughout this whole video. See that title here on my slate. So, I have spent about a week of intense research looking at every possible image I can find of the tuning fork and comparing it against every measurement statistic I have. And I believe that I have come up with a measurement of 68 inches. When you're dealing with something this 68 inches is the measurement. The difficulty with a rifle like the Mandalorian's rifle is 68 inches is long. That's longer than my wife is tall. That's 5'8". Which means every photo you take of the rifle is going, like if you take it from the middle, the ends are going to be distorted in terms of their size relationship to the middle. If you take it at one end, the same is true of the other end. If you take it at the other end, right? So this is a place where I get all caught up. Like I think, I really want it to be exact, but I have concluded that the important measurement for me personally, in my experience, is the 68 inches. That, I know that, I feel confident about that measurement, I'm going with it. So to that end, I went online and I looked at some different STLs that people had drawn of the Mando rifle. And I found one on Etsy that seemed very accurate for all the details I could take a look at, and I bought it. I'm going to start printing it out. It may be that it's not quite the right size or that I need to adjust some aspects of its size. That's all to be seen. But for right now, it's several dozen STL files, and I'm going to compile them and send them to the Form printer and start printing out Mando rifle chunks. Ooh, very exciting. Hey, the moment of truth. This is Norm Chan said to me that owning a 3D printer, like a resin printer, was like Christmas every morning. Just like every morning, what comes out of it. I sent one of the most difficult parts of the rifle, which is I wanted the whole tuning fork to be a single piece, the whole front fork thing. And it's just a little bit bigger than can fit in the bed, so I had to tilt it, and I had to work really hard with its supports in order to make that work, but I think I got it. And we're about to take a look. Here we go. Oh man. Look at this. Set it going one night, come back the next morning. Got the tower of power. Oh, so pretty. Nice. It's like a cityscape, right? And the tuning fork looks really good. Time for the cleaning. I've built a workstation here for the cleaning. This is the tank that Formlabs makes. It's great for holding on to the alcohol. And I'm just gonna, work towards getting all this stuff off of here. And then we'll start doing the cleanup and the final prep. Okay. Nice, that separates beautifully. Oh, dude. Are you kidding me? I love it. Oh, I think this partner and I are going to be very happy together. Wow, look at those supports. That's kind of awesome. It's standing over a vat of isopropyl alcohol can get a little smelly. All right, that. One of the reasons, sorry, my hair is crazy today. One of the reasons that I chose this model is because this modeler managed to really see and replicate all of this fascinating detail in the inside of the tuning fork. Yeah, it's a really nice drawing. Oh yeah, patience, young Padawan. That's how to separate your model from the tree. There we are. Okay, I'm gonna put that there and this down here, and I want to clean that off. So I'm gonna swap out my gloves. Form has seen fit to actually provide a couple of registration fins in this piece to hold on to this. It's brilliant. It's a really nice feature. Yeah, I dig it. Oh. By the way, on the day that we were recording this, on the day that I'm recording this, film legend Yaphet Kotto passed away last night. He played Parker in Alien. He's in Midnight Run. He's in Homicide, Life on the Streets, Live and Let Die. A legendary and amazing actor, legendary human being, and I'm sad that he's gone. Yeah, Yaphet Kotto, R.I.P. man. Peace. All right, just wanted to make sure you knew. I need a fan blowing across here is what I need. I know I should be more careful. Look, I'm pulling off these supports, and I know I should probably be more careful at it. But I've run this first print in the lowest resolution, the 0.2 millimeters. So that this is just a draft, right? Like once I get these parts to where I like them, and I'm sure I like their size, I will probably reprint a bunch of them. And then I will probably, I'll probably reprint a bunch of them, and then I will probably make some of them out of metal. Because, well, as you can imagine, this rifle's got to feel real to me, so a whole bunch of it's going to be made out of metal. Let's be clear about that. Let's be clear about that. All right, this is the trigger. My only question is, how much do these resins creep over time? That's the one thing I'm not sure about. You know, sometimes some resins move a little bit. I wonder how stable these resins are. That is not a question I know the answer to right now. All right. Hi. This is a cooking show, and I'm about to put my pieces in the oven. I think I could do a little more rinsing on each one. 2, 3, 4. Now, what I'm doing is I'm bathing it in ultraviolet light, so I'm curing the final outer layer of these pieces. I'm going to let them sit in this UV for probably only about 20 minutes. But we will, nice. All right. You stay in there and think about what you did, and I will be. Oh, one more piece, huh? There you are. All right. At the beginning of this project, I've got to fess up. I made something off camera. Yeah, I did. I had some. All right. I had some extra walnut. And I made this part. I'm sorry I made this off camera. To just give you an idea, I traced out its shape based on some blow-up drawings I did of several pieces of the rifle. Then I got my scale correct, 68 inches, and I scaled this into that, and then I cut it out and then slowly planed it with finger planes and then sanders, and eventually this will get a nice finish. And once it starts getting beat up, man, it's going to look so damn good. Yeah, sorry I made that off camera. Let's start lining up some parts. Why not? All right, it's been about 20 minutes, and I've been going through the various file stacks of pieces of this rifle. My parts have been spinning in their little UV oven, and I've been like looking at this list of the parts from the Etsy seller, and it's parts management. That's what's going on in my head. Parts management is a tricky new aspect for my head in 3D printing, because normally I'm making every single part from scratch, so I have a personal relationship with every single part and piece. In this, I print out a whole bunch, and I'm not sure where I am in the stack. So it's just requiring for me a little more assiduousness in knowing that what I've printed, what I still need to print, what I've got going, and what I plan to make out of metal, if anything. So, yeah. So let's see how we've done here. These guys, they still feel a little bit soft, so I'm going to keep them. Well, they still feel a little tacky, so I'm just, yeah. I'm going to let everything go a little bit longer, and we'll start assembling. Okay, we're making progress. I'm trying to wrap my head around this this rifle, and I think my head is wrapped around it. All of the parts you see on here, this is me getting to know this printer. Ooh, sorry, it's a little chilly in here right now. All of this is me getting to know this printer. This is, I think, roughly 2 runs of many parts of this gun in draft resin, in a couple of different sizes, because the first size I had wasn't perfect. I also have some sintered nylon pieces from a different ambar rifle set of STLs that weren't close. They were free online, and they weren't. They didn't come close to what I was hoping for. But my Etsy seller, my Etsy rifle is, all the parts are now exactly the right size. Got this beautiful tuning fork here. I'm really happy with this. But again, this is draft resin. So this resin can creep. It's not as durable. I'm actually going to do this out of their tough resin. And I think I figured out the list of parts that I am going to do in their tough resin. And it's going to be, we've got the tuning fork, the thing right behind the tuning fork, the full octagon, the grips, the scope I'm going to make entirely out of aluminum. The scope mounts I'm going to make out of brass. And then there is, there's this part, right? This is the breech loading part. This is where the cartridges go in, and Mando, lights his thing. Then there's the trigger and the stock. So I think that most of these parts I'm going to print also out of the tough resin. I'm going to make the trigger and the whole trigger housing out of aluminum. And the stock is going to stay this beautiful walnut. And it's too long right now, which is ideal. I'm not shortening the stock until I'm really dialed in here. But those are the main parts. There are some detail parts within this, which I may also make out of aluminum here and there. There is a catch, a spring-loaded catch built into the breech loader. I am not going to start mechanically problem-solving the spring arrangement and the locking arrangement for that yet, because this is the draft resin. And basically, one of the things about resin is that unlike filament printers, you can't have big voids inside, right? Filament printers are all about like how much infill you have. You're never making anything like fully 100%. But resin printers, because the resin is liquid, has to go somewhere. You can't have big voids inside, which means you end up with chunks like this that are like mostly solid. And again, these could be drawn as shells, that's to be sure. I don't have that skill just yet. So what I'm likely going to be doing is printing out the masters and then doing my version of mechanical problem solving, which is to chuck these things into the mill and milling out the spaces and spots that I need to. Also, I don't want it to be too heavy. But yeah, I was going to say we're close. We're not close from a construction standpoint, but in my head, I feel way more like my head is wrapped around what this gun is about than I was before. Oh, also, all the main barrel parts that I can, I'm going to make out of metal, without, obviously, because they'll just look better, feel better, last longer, and won't bend. Okay. So what's incumbent on me now is to make a platform in form of these pieces and start to run them in the tough resin while I am going to work on the trigger and stock marrying. And I'll give this a micro switch so that when I pull the trigger, it actually does something. I'm not sure what that something will be, but I'll include the option. All right, time for some computer drawing. Not computer drawing, more like setup. The tuning fork, a little flag before the tuning fork, the octagon, the grips, these pieces that hold that small barrel, and then there's this whole arrangement with this guy, right? That business. These things are solid. All right, so because I'm changing out the resin, I've pulled out the build tray for my draft resin, and I'm putting in a build tray for durable resin. I'm gonna put the mixer in. Tough. This is a Tough 2000 version 1. Really would be remiss if I didn't thank Formlabs again for their generosity and giving me all the toys and tools to play with this thing. I must say the cleaning and washing of parts is incredibly laborious. The parts are amazing. Yeah. All right. Let's see. That comes out, and then this comes out. Yes. So you crack the tops so that we can run freely. There's one. Top is in. This goes in there. Okay, both of those are open. Now let's just get my computer to wake up to what we've got here. All right, I'm waiting to auto-generate my supports for all this. I think I've got a complete, I think I have a complete thing here. We'll see. The pike sits below. The pike is the tuning fork. Octagon barrel. Yeah, I mean, this should all work. Aside from a couple of cups, I think we're doing pretty good. I don't see any red outlines. None of my prints fall over each other. They come close. I've also updated the printer. So once this is drawn, I'll send it. And again, this will be in the durable resin. I'm not sure how long this print's going to take, but it's likely to be, you know, I think over a dozen hours. Yeah, you're clear there, you're clear there, you're clear there, you're clear there, you're clear everywhere. Yeah, let's send it. I like this. I'm going to save it. Tough resin ambar. Oh, I got to install I got to download an update. So one of the things you're going to run into with this kind of technology right now is that the companies, specifically Form right now, is improving this stuff all the time. And the improvement is both across the software written for the machine and for the interface with that machine. So I just ran into this thing where I installed an upload of new software for the printer, but I hadn't updated preform, and thus, even though I had built up a whole raft of parts, it was incompatible. So I had to download and update the software for preform on the computer. It's just, again, part of the cost of business on this is that this is still a nascent technology. All right, are we loaded? Okay, I want to track print online. Let's see. And right, I think I can click print here. Yeah. Oh, I don't want, lest I show anything personal, I'm just going to close my laptop. Oh, print. Press open on the vent. That is these guys, these little vents back here on the tops, and they are both open. Yep. Okay. So, next. Yep. The clasp is down. Confirm. And it's going to print. All right. It's going to take a while. It's definitely going to take a while. But in the meantime, let's make a trigger. So here are the three parts that I want to manufacture here. This is the trigger body. This is the trigger guard. And that's the trigger. So I want to find pieces of aluminum that are close to each of these. Better. Oh, come on. Oh, I recognize what that is. Yeah, that's a cutout, but just wait. No, I think I could get you out of there. Yeah, that's good for the trigger. And then this guy, I guess it is this. Yeah, I mean, it's so freaking close. All right, so I've done some layout here. I have covered this with blue. I have covered this with blue, and I have actually already drawn this for the trigger guard. And I'm going to lose a couple of little bits of these sharp corners here, but that's fine. Being able to utilize this piece is more important than getting a perfect edge like right there. Yeah. So I'm going to do some preliminary slicing. Great. That's a nice trigger. Excellent. Okay, so there's that. Then there's this guy. All right, I changed my mind about the trigger guard. I went with a bigger piece because I wanted to have a handle on it. And I've gone with the tried and true method of drilling lots of little holes to make sawing out this plug easier. And I'm actually not going to saw out this one until later so that I have full access to this for filing it out. This one I'm going to take onto the mill and smooth out that side, and then I'm going to machine it to thickness, whoop, like this, and then I'll worry about the details. And this one, well, this one I'm going to draw. Again, because I was actually, it's a long story, but I had to find a better piece of metal. So here it is. Okay, there's my trigger shape. And we're going to do the same thing here with this, just drill a few holes to make that a little bit. there we are. Some 3D printed parts over here. Trigger guard, housing, same over here. I've followed the form factor. There's probably some aspects of the inside that I didn't need to get exactly right, but that's fine. This will be great. And I've marked out the center hole for attaching that. And this curve here will actually get adjusted to the curve of the stock once it goes in. That'll get actually this whole like separate compound curve. But for right now, got this nice display of the 3D printed parts and their aluminum counterparts. I've been, whoa, Muppet hair. I have been slowly cutting into my stock, my Ambar rifle stock, and I've made a slot here and I made a slot here because there's metal on both of those. There's also, there's this big curved piece of metal back here, and I am going to do that one. It's just going to be a big pain in the ass, so I'm going to wait. Yeah, I'm not in a rush to do this one, but I've got some nice trigger parts here. There is, yep. This is all starting to look like a genuine thing, and I think we can start to put parts of it together. This goes there. Yep. And nice. Excellent. Once again, when you're doing 2 screws into a thing, get them both in loosely before you tighten them. Excellent. Okay, so now this goes in here. Are you ready? Oh, so pretty. Ooh. Let's get a screw in there. Tighten it down. Excellent. I drilled this one off center. I messed it up a little bit. I don't mind. It makes it feel more like the real thing. So I accidentally screwed up and I made this a through hole when it was supposed to be a stepped hole. So I have to work out a solution. But the top of the rifle has this metal strip up here. So I put in the slot and I put in the strip. And I've carried it forward because I'm going to utilize all the structure I can. If I don't need it, I can cut it off. But if I do need it, it's there. And so that's the hand manufactured parts of my Ambar rifle. I still need to work out the engineering, but parts are still printing. That raft of parts I sent it yesterday morning and it won't be done until tomorrow around this time. Yeah, tomorrow afternoon. It's crazy, but you know, high level of precision print on a stereolithography machine. It's going to take some time. I'm really, really happy about this. I'm dreading this. This is something that's just striking me as just like, blah, blah, blah. How do I do that? I mean, I suppose I could just take a Dremel and just do it, but also, I mean, I could chuck this into the mill and do most of that, right? I can't do any of that, but I could get all the way from here to there, right? Yeah, I mean, I could. I may have to make a tiny little plate that goes on the underside of this that allows it to be a countersunk thing. Like little 172 screws blind tapped from the back. I mean, I guess I could also mill out a slot, put in a little piece of aluminum and TIG it in. But this is, I'm happy so far. I'm happy so far. This is great. There's no flathead screws visible on Mando's rifle, but I put one in. And I'm putting in a couple. Yeah. How am I going to do this? If it was Peter Lyon, he'd just sit there at his desk with a Dremel and be like, "Meow, meow, 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 meow." Peter Lyon is the sword master at Weta. And almost every time I go, I see him working on some exceedingly fine, perfect detail on a sword. Like, yeah. Is mine going to fire anything? I don't know. I know I have to do those 3 holes there too, but that's fairly straightforward. That's pretty simple. All right. Once I get those parts out, we can make some real progress. Okay, I have a solution for making this from a through hole into a countersunk hole. Hang on. So the problem I had was I had this screw, and I wanted this to be the screw that... Sorry. There we go. The problem is I had this hole, and I had this screw, and I wanted the hole to stop this screw. And I accidentally drilled all the way through because I had a really sharp drill bit. So what I have done is I have milled a slot in the back of this. Ooh, there it is. See the slot? And I have, that's not blood, that's Dieckman. I have made a little piece that slips into that slot. I'm going to join them, and I'm going to join them, and then I'm going to make my countersunk hole there. So here's the piece. This slips in here, goes here on the top. And I wanted to hold it down. I wanted to hold it down with this screw. So I drilled a hole, and then I made a countersunk hole, and I accidentally carried it all the way through. So what I'm doing is I milled a slot in the bottom here, and I milled a slot in the bottom, and I've got a piece that fits that slot. I'm going to put it in. Yeah, there we go, like that. And now I'm going to take a punch and punch on both sides and really kind of join these two together, toss in a little crazy glue, and then I'm going to countersink it. Yeah! All right, there we go. We're back in business. I'm pretty pleased. It's got a nice solid hold. Look, it's not, this isn't a super strong engineering joint, but it's a perfect solution for just fixing this right now. Yeah, I'm going to put a threaded insert. What is a threaded insert? This is a great question. I will tell you. When I am doing something like attaching something to a piece of wood using a machine screw, this is a 632, which means it's a size 6 with 32 threads per inch. When I want to hold on to this, these threads, I mean, yeah, I don't have to give you a super close-up. You know what threads look like. They've got to grab those little angles, 60-degree angles of the threads have to grab the wood. And the wood is soft, and the metal is harder. I mean, it's a soft metal, it's brass, but it's very easy to strip out the holes in wood when you're trying to hold onto it with a machine screw. Enter the threaded insert. I am going to show you a big threaded insert. Actually, let's show you a really big one. 3/8 16. So let's show you a big threaded insert. Let's say you have a hole in aluminum that's 3/8 and it's munged out. So it's a piece of aluminum like this that was tapped and threaded for 3/8 16. Is that right? Yeah, 3/8 16. When that hole is stripped out, what do? You can't make more metal. I mean, you could weld the hole and then re-drill and tap it, or you could drill it out with a larger drill, tap it out with a larger tap. Now, this is a threaded insert tap. And what this does is this opens up the hole wider for a specific thread pitch, which is this pitch. And this is this hardened steel spring, and it looks like a spring, but if you were to cut this spring and look at the wire, it would be in a diamond shape, like this, 60 degrees, 60-degree angles. So what this is effectively a thread for a 3/8 16, and you are putting new threads into a hole. This is a beautiful solution for engineering into wood. especially for small screw sizes. They make these down to 256, and the biggest ones I've got here are, do I have half inchers? No, 3/8/16 is the biggest one I have. So there it is. This is a threaded insert. I will, I'll show you in close-up how this actually works. So right here, here is where my hole is going to go. That's to allow this to go in there. And I am going to drill it out with the proper drill size for this threaded insert. These are the 632s. And then I will tap it. All right. Now we're going to tap it. And you know what? I like adding a little oil to my tap, even for wood. So I'm going to use a little bit of this Molly D. I know it's way overkill for this, but here we go. If I was doing this into a different material like Delrin, I might use the drill, but for wood, tap wrench gives me just much better feeling. Okay. That goes back in. This is the threaded insert insertion tool. And here are the little tiny 632 threaded inserts. I just need one. So the threaded insert goes on the insert tool, and it's got this little, the way you're able to put it in. You see that little piece crossing the hole? That's a little piece of spring steel. And it provides a stop on the insert tool, so the insert tool can actually pull the threads in. It really takes only finger strength to put this in. There we go. Now, like I showed you, I've got that little piece of wire across the hole. All you do is you bring over just a rod like this, and you give that rod a little thwack like this. There we go. Because the spring, there we go. This is what that piece looks like. And because this is hardened steel and it's got this little notch here, it actually breaks off. So it allows you to install it, and then you shatter that off with just a little bit of a tappy thwack. Tappy thwack! There, that goes there. It's right. See that? And I can finger tighten that almost all the way down. Watch this. Oh. There we go. Nice. There we go. Hi, everybody. So, the Mando rifle proceeds apace, and a very exciting development has happened. The stock is ready to have parts mounted to it, and said parts have come out of the printer and have been properly washed in a 15-minute long agitated bath of isopropyl alcohol, several passes of scrubbing and air blowing, and they feel good. It's really nice. It's a nice model. It's a highly accurate model. And this is my first time feeling official parts. This is a Formlabs Tough Resin 2000 V1. And I really like how it feels. I like its weight. It feels like it's got a little bit lower of a specific gravity than the draft resin. But I've got some parts here. I am going to remove the support material and then do a final ultraviolet cure on these. And then it's actually going to be time to start like attaching these things to each other. That's yeah. Very exciting. Very exciting. It's lovely to see these parts and see them. So let me get this material off, and we'll start to figure out how to work with these. I'm really, the post-processing is real. You know, it's like I know that the public perception of 3D printing is that you push a button and something comes out, but no matter what the process, there's still a lot of work on either side of the equation. We don't quite have the Star Trek replicator yet. Not that I expected we would, but you know, it's good for everyone's expectations to be set correctly, including mine. And you know, it's a real thing to make sure you've gotten rid of all the uncured resin. I've read into a bunch of forums and talked to some friends who use these professionally, and the best practices really work. Making sure you've washed it for long enough, making sure that you have scrubbed it and let it dry, letting the first isopropyl alcohol wash dry for 24 hours was something a friend told me, and it really looks like it worked gangbusters. Okay, I'm going to stop talking and start working. That's how this is going to work. I will tell you, I can feel, I've gone with the sprue connection here is 40.4 millimeters instead of the standard 0.6 that they set it at. And even with this lighter one, I can feel how tough this resin is. How tough this resin is. Yes, as advertised, the tough resin is tough. The 15-minute post-cure is done. And I think that means that I can pull my parts out of my 3D printing discotheque and actually start to work with them. They all feel amazing. This is really exciting. A couple things I did not realize about 3D printing is how much of it is parts management. Like, you end up with all these, like, dozens and dozens of files for each thing you're making. And keeping track of what you're printing, what you have printed in what material, and where it's at within the production process, non-trivial. I missed a couple parts. They're printing behind me. They should be done this afternoon. But that won't stop me from the engineering that I need to do right now. So what I've been doing is slowly engineering these two pieces, which make the main continuation of the rifle after the butt. I've been basically just adding some screw threads so I can screw these together. That's the next thing I'm going to do. I'm starting with the stock with the nice amount of meat I've got to grab onto here, and I'm just moving forward. First up, we do this one. Now, the thing about these two is that both of the screws that go into this go through both. So we got a really nice grab. Come on, hold on. There you go. There's one. So now here's what I have. The butt is mostly complete. The trigger arrangement is attached to the butt. And now I've got a screw that goes from here, in through here into here, and another screw that comes from here, down through here into here. I know I got a little bit of a broken spot there. That's because the resin is a little more brittle than I'm used to, but I'm getting to learn it. All right. Now, it's just about moving forward. Oh, progress, progress. Oh, it's proceeding faster than I thought it would. And it's all really exciting. I'm here now. My butt, which is made out of walnut, has an aluminum trigger assembly and is firmly and beautifully mounted to the cartridge assembly of the Ambar rifle. The next stage is to attach this front part, which goes there, and then start to attach all the barrels and eventually the tuning fork tip. I'm going to do some machining here. I'm going to make this part out of Delrin instead of 3D printing it. It is a really straightforward part. It's easy for me to make, and so I shall. I can't remember which way this goes, but I'll figure that out. I am also going to build the scope from scratch. I actually have this beautiful, where is it? beautiful piece of aluminum for the scope. It's perfect in the size, and it's actually got this nice center bore. So this is like a 1-inch tube with a 1/2-inch hole. So it's got 1/4-inch wall thickness. This just in. You can buy aluminum round tube in almost any like outer inner combo you want. Okay, not any one you want, but like a wide range of wall thicknesses are available. I know my hair is crazy. I know. It's just what happens in the morning. Good morning, everybody. So the next thing I'm going to be doing is, right. Sorry. This goes here, and I've got to mount that to that, and then this goes here. I am so sorry. This is the next stage, is to provide a... All right, so mechanically, here's where we're at. I've got like 40 plus inches of barrel to attach to this part of my rifle. This is where I'm at right now. This will go here, and actually I think it goes like this. Yep. And then, no, actually it goes like this. That's 1 out of 4. Anyway, so I'm at the end of where my hand is will be 40 plus inches of barrel. That's a lot of torsion on this joint here. So I want to make it very strong. So I think the first thing I'm going to do is actually, I am going to use 2 screws to join this piece to the cartridge assembly. That's the next stage. Then once I've done that, then it's time to, I'm going to machine this piece out of Delrin instead of 3D printing it, because I actually think I want to make some long tabs on it that connect into this thing. Yeah. And I'm also probably going to remove, after I finish all that, I'm probably going to remove some meat from the inside of this cartridge assembly, just so that I remove some of the overall mass. That's just one of the things that I've been considering. Yeah. Here we go. Hi, crazy hair. You probably noticed that the 3D printed part. Hold on. You've probably noticed that the 3D printed part that fits on the front of here has these facets to it, and I did not follow those facets in making the part that I was making out of Delrin, because I found some reference of screenshots that make this piece just forward of the barrel. All right, yeah, there. It doesn't have facets. It's actually rounded. I have some other STLs that are more rounded, but they're not the right scale. So I've just modified this one to fit the other parts of the 3D prints. I like this relationship. I like this relationship. I'll have some detail parts here. It is nice and solid. Grabbed, and then I have a hole here in the bottom of this, which actually screws this part all the way into this part. Yeah, with a threaded insert. It's nice and strong. So now I'm just going to take this onto the sander and finish it off. Coming along. I'm going to sling this over my back any minute now. Okay, so we're almost at the last engineering challenge here. This is great. I'm really happy with this piece. As you can see, it's way less faceted than the 3D printing model. It's the only part of this. There's two parts of this I found that were slightly less than perfectly accurate. That and this piece, this shroud that covers over the front of the breech part. It's just a little bit fat. I think it's a little bit too fat here, but reducing its thickness is a real project. I may do it. I probably won't. We'll see. So the next challenge for me is the fork, the business end here. So this is the tuning fork, and this has got to go out on the end of this barrel. So far, I'm really happy with how this whole thing is mechanically connected. I've got screws holding these two parts together. I've got one screw coming up from here through into this part. I've got one screw coming down from here into this part. This is mounted with two screws coming through into the main body. This is mounted with a 1/4-20 screw that goes through this and into this. Really nice. This tube goes all the way to the back of this and goes up to about here. Then this continues on this, and this brass tube sits in the middle of these two octagons. I will have to, finish that seam and make that one single part. But now the question is, how do I get the fork on the end? This is going to take all the abuse, right? Everywhere you're moving this bit of costume, you're going to be banging this, right? Now, I already molded it out of the Form Tough 2000 V1, and I really like how tough and flexible it is. So the material I printed it out of hopefully will aid me in this not destroying itself when you're moving it around. But the other thing is that it's got to mount to the end of the barrel. It's got to mount right there. And I can't just glue it. I need some structure inside this. So what I'm going to do is I'm actually going to chuck this into the mill using a pin up its center here, chucked into my collet on the mill, and I'm going to guide this into the vise, holding onto it with a couple big pieces of wood and some clamps. And then I'm going to open this hole up to receive the tap for this 1/2-inch threaded rod. The 1/2-inch threaded rod should give me the strength that I need to go all the way into this front piece. Yeah, this is the only 3D printed part on this gun that is not 3D printed here in my cave. This is printed by some friends of mine in sintered nylon. It just happened to be a more accurate piece. I've been running sample parts of this rifle for a couple of months now. Little runs here and there to kind of wrap my head around the structure and understand it. Going to end up with a box of semi-accurate parts when all this is done. All right. So I think I have my marching orders. Got to get this fork. See, let me just explain why this is an interesting problem to solve. This hole that is through here, you can see it. There you go. It's got some support material which I can get out, but that hole is parallel. But if I tried to widen that hole, there's a lot of opportunity for it to get less parallel. And that's, sometimes it doesn't matter. For this, it totally matters because every bit that this is off is going to look and feel off. It's a long cantilevered piece. Straightness, it's like your eye is going to be able to see quite clearly that it is not straight when it is not straight, and that's going to be problematic. So the mill is how I'm going to solve that problem. I know. I just said that I was going to go onto the mill and do this whole thing with this, and then I realized I could creep up the diameter of this hole a 32nd of an inch at a time, 30 thou. That's 15 thou on either side of the diameter. Given that, it is possible to maintain a relatively good concentricity. I even... on the last one, I just did a thing where I like spun it in the drill and my hand went in here and I put my finger down here and like it cleared, right? So these are turning on center still. Not a very scientific way to figure it out, but good enough for me. Good enough for government work. All right. I did actually, so I turned down the very front of this 1/2-inch rod and drilled a little hole. So hopefully we will be able to see a little barrel sticking out there. I'm just gonna put this in now. See how it works. Well, it's a nice fit. This tough resin, this tough stuff takes threads well. That's for sure. I'm going to need to get a little gription just to continue with the last bit. Hold on. All right, I've tapped the hole. I'm putting in the, look at that. Yeah, I like it. I like a little bit of steel poking out there. That's great. Okay, so tuning fork is ready to be mounted. I just have to figure out, yeah. Good. All right. That might have been it. Yep. It's happening. It's happening. It's beautiful. All right. Now, it tightens up really nicely Come on. Oh, is that it? That is great. That's one part. Okay, let's see how well. Right. This is only the last mechanical problem to solve, or the last big structural mechanical problem to solve. There's still a host of some other problems to still solve. But this was once I've got this, let's start to actually think about some other stuff. Okay, so let's bring that out just a tiny bit. Great. Okay. Let's see if it, feel like I'm loading a musket. All right. So I'm off by a tiny bit. I'm off by that much. I just have to shorten my brass pipe by that. But, dude and dudettes, this is an almost impossible thing to photograph. Yeah, there's the whole structure. The disruptor structure. Oh, yeah. Take care of a crate dragon. Yeah, that is, you really recognize that from the show, right? It's like this comes way down. Yeah, that's really neat. All right. Got a little detail I'm going to put in here. That's the 3D printed part, but to fit the ridges in there with the slightly raised barrel arrangement, I made a vacuum form of it. And I used a brand new vacuum forming machine. We have a one-day build for that new vacuum forming machine in the comments below. It's like just over $100. And oh yeah, that'll work perfectly in there. But I'm getting ahead of myself. I'm just really like kind of excited that this is, the form of this is mostly complete. And now I can have fun with the aesthetics. Oh, this is gonna be a fun paint job. Yeah. 58 inches, man. 5 foot, 8 inches. It's big, big thing. All right, there's my scope. You know, I've taken a bunch of screen grabs of some museum exhibits. I think there was something at the ArcLight. I don't know exactly where all my reference material came from, but you know, just tons and tons of Google searches of Mandalorian and his rifle. And I finally found some pictures and allowed me to break out the measurements of his scope to my satisfaction. And that's the next step. I'm going to build his scope. I'm going to build Mandalorian scope for the Ambar rifle out of aluminum. I'm not going to 3D print it. I have a 3D printed version of it. It's not as accurate as I would like it to be. And also, this is a part that's like sticking out. So there's like 2 brass arms that hold onto it. I'm going to make the whole thing out of brass and aluminum. So it's like a nice robust part of the build. It's going to take a little while. This is like kind of its own knockout little build, but I should be able to do it in 3 or 4 hours, half a day. We'll see. I love this process of like taking all the screenshots and figuring out how to make them work until I get something that I can actually machine with. Yeah. I have long heard that WD-40 works great as a polish on aluminum. I'm here to say it works. It's got a beautiful polish using WD-40. Dude, Mandoscope. Yeah, there's all sorts of little things that aren't perfect about this, but yeah. Ultimately, I'm really happy with how it looks and feels. So, we just completed this. It's totally wrong. It's not totally wrong. Look, I collect reference material from all over, and I attempt to sort it into buckets that are like fan makes, commercial remakes, official movie remakes, screenshots. Like I really try and divide up my information so I understand the sources it came from. And I had what I thought was a shot of the real Mando rifle. And then I found this sequence of Mando loading the breech on his ambar rifle. And suffice to say, this doesn't look correct at all. I'm about to print it up again. Luckily, I have one more piece of this 1/2-inch ID, 1-inch OD aluminum. So I'm going to do it again. This is not a bad test run. I am still getting to know this multi-fix system of tool holding. It's an adjustment because I've been using Aloris BXAs forever. But I really like the angularity of the multi-fix. It's a lovely thing. I even bought it for a lathe that I don't even have in this shop. I bought a separate system for my other Shenhua lathe. At any rate, this happens all the time. You make something, you realize when you look at the reference material you had that it's not right. Got to do it again. Sometimes I get so upset with myself, it takes me a week. Sometimes I'm like, I put away the project and I come back to it months later. Today, only an hour later, I'm going to remake the same part again. I mean, yeah. C'est la vie. Here we go. Okay, so I need my live center in here. Oh, there they are. Excellent. Occasionally when one is lathing, one ends up with a little ring like this that is like a cutoff, and I kind of love those so much, I save them. So here, oh, whoops. Oh, yeah, I see. So here is my collection of lathe cutoff rings. Who knows what I'll eventually use them for, but I don't throw anything out over here. That's not necessarily an encomium. Okay, so I've got this set up. I'm going to still do a turn down to the diameter because it's 0.925. Right, but this is... I got to remake this. Okay. Okay, so here's a piece of reference that's not enough reference for me. This is one of the stunt ambar rifles slung over Mando's shoulder. It's good for some proportional details, but not enough for the other stuff. Here's the other piece of reference that I found. It is a shot of him of him loading the ambar rifle. And since this is taken from an actual screenshot, I will say that I consider this to be, oh, come on. Yeah, there we go. That's canon. I mean, so it's entirely possible that I followed reference on some behind the scenes prototype I found online, or there might be different there might be different scopes for the 2 different seasons. I don't know. I don't need to know. Just suffice to say that this one, I'm not happy with it. So I'm going to chuck its reference, and I'm going to go with this reference. So now what I'm going to do is I'm going to take this, clip it, put it into Photoshop, straighten it out, print it out the actual size, 7.9 inches, plus or minus 50 thou. And then I'm going to take measurements off the actual piece of paper. I'm going to take measurements off the piece of paper, and then I'm going to use those to transfer to my piece of aluminum chucked into the lathe. Just waiting for it to print. Sometimes I send a print. Takes my HP laser printer like 25 minutes to spool up a single print. I wish I knew why. Okay, we're good. So here is my reference now printed out. And again, look, I'm gonna have some camera parallaxing, and there's not much of a way I can take care of that. So because at this end, it's fairly straight on, whereas this end, it's at this angle. If I held this up against the original, some of those measurements just aren't going to track perfectly. But again, it's only a precision problem, not an aesthetic or visual problem. So I will follow these steps and critical measurements to remake a plan for just how big this scope is. Here we go. That's the new set of measurements. Looks like to be a outer diameter of a maximum outer diameter of actually this one. Sorry, the outer lip. Oh right, yeah. Okay, so the outer diameter is 0.85 with this, and this all having minimal dimensions of 0.75. These bumps are both 0.85, and then this little arrangement in the middle, I'm going to have to. There's some of it's a little blurry. I'm just going to have to make some calls there. And then this and this diameter, those are both Hang on, what are those diameters? 0.7. Yeah, 0.7. All right. Yeah. Diameter of the bottom ones of the inside here, 0.7. Oh, right. Yeah. Okay. I'm just gonna have to drill these out differently. These are gonna be the brass holders that hold on to it. I'm making them from scratch, but that should be fairly easy. Okay. To the lathe, boy wonder. Look at that. My goal was 0.85. That is 0.85. That is dead on the money. It didn't need to be dead on the money, but that's good practice. Okay, so now it's time to, now I've got this thing turned down to its important measurement. All right, so now that I've marked it out, I have 3 levels here. I've got the outer level, which is 0.85. Then I've got the slightly lower level, which is 0.75. And then I've got the lowest level, which is 0.7. So we'll touch off on the outside, and then we'll zero it out. So now I'm going to take this in. 100 thou, right? Yeah, from 0.85. Just double checking. Yeah, 0.85 to 0.75, so 100 thou. For the record, that was a final pass with the lathing bit, then an application of some 220 grit sandpaper to take out the machining marks, then Scotch-Brite, the brown stuff, and then some quadruple zero steel wool with WD-40. And I think that is a good looking scope. Let's cut it off. Yeah, let's cut it off and see how it works. There we go. Whoop. There we go. Oh, yeah. And let's take a look at the reference material. Yep. Oh! What the? Oh. After all that, I totally forgot about these two rings up here. These two bumps. What a dope. Maybe I'll... For right now, this is fine. So that is the notch that will fit the standoff that will hold on to the scope. Oh, that's not a bad part. Couple little doodads there. Yeah. I know, it's not click spring, but it's pretty darn good. Yeah, lathe grip. All right, I have completed this part. This is the barrel stand for the scope. I am about to cut right there. See that black line? I'm cutting right past center so that hopefully this will actually grab the scope. Yeah, we'll see. So I've cut it just past center, right? So up to center, the lines are parallel, but past center, they're tangential this way. So hopefully this is coming up a little bit and it'll actually grab the scope. See that? See, it doesn't sit all the way in. Oh, come on. Come on. Just wait. Sorry. I gotta look at my reference material here for a second. Okay, so the long one is on the other side, and that goes right about there. Nope. This is that one. Goes right there. Yep. Okay, so. Hey! Oh! Nailed it! Oh. I might be overly excited about this, but that's pretty cool. I'm pretty happy with that. Okay, so if that's the case, then this sits here. Let's see here. Oh, damn, that's sweet. Okay, so, oh, right, okay, it comes off of this thing. Right, so this guy is going to be the same deal. Let's see here. So then I'm going to have to cut this down, and it's a little, is it just a tiny bit too long? I cut it there. It's possible that I'm done. Okay, here we go. Time for the assembly. The assembly. Right. This is, yeah, all right. Yep. That's one. And then, oh, trigger, right. Let me get out some springs. Come on, little doggy. That's it. Oh, will you actually not work there? Oh, you won't. You gotta work there. Dude, did I really just get that? I did. Hey! Awesome. I'm not sure. I wasn't sure I could do that. Okay, so we put this in here. Comme ça. Yes, there we go. Nice. Next is this bad boy. Still didn't find the right one, but you got the breech load locks. Good. This guy goes in here. So I'm going to put this in here, right? Come on. All right. That's it. There you are. Come on. That's it. I think that's properly deburred. Yes, 'tis. All right, so now these guys, wait a second. Right. Now that sits like that. This. Oh, oh. That there. That there. That's it. Oh. That goes here. Oh, yeah. Oh, yeah. Dude. Okay, some details. All right, I've added I've added the little, and I've given a coat of primer to the rifle. I'm gonna use a little furniture polish right now, just to bring the shine on this up a little bit. See what I can get. Just gonna let it soak all that in. Ah, there we go. Yeah. Mm-hmm. All right. Where should you live? You should live probably right here. And there it is. Perhaps the most difficult to film prop I have ever built because of its crazy length. Yeah, here she is. This is the Mandalorian's Ambar disruptor rifle. I think I'm missing something in there. I've taken this a little farther than many of my mechanical constructions in that I've given it its final coat of gloss black for its finish coat. And that will be a totally separate video, but it is ready. I'm really pleased with how solid this feels, and I'm pleased with its aesthetic fidelity. It is just gorgeous, and I cannot wait to paint the burnt metal pattern on this tuning fork. That's going to be the hardest part, and it's probably going to be the first part of the next video. Thank you guys for joining me for this one-day build. I will see you next time. Thank you guys so much for watching that entire video. If you would like to support Tested even further, well, I'm here to tell you that you could become a member. If you follow the links below, you'll see there are several tiers of membership depending on how much you'd like to pay and how much access you would like to me and the Tested team. And membership comes, as always, with some excellent benefits, including questions that I'll answer in live streams. The questions have been so amazing, and exclusive videos and exclusive content. Follow the links below, and we will see you next time.